Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter hyperbolic functions, lecture number 3, in which I will find the periods of hyperbolic functions and expand sin hyperbolic x and cos hyperbolic x in series. Now we discuss about periods of hyperbolic functions. Before knowing the periods of hyperbolic functions, I would like to give you the concept of period of a function. Let x be a real number and f be a function defined on domain D to a real number. This is the domain D. This is also real number and this is real number. This is a function f such that for least positive value t, f x plus t equal to fx. That means the function f repeats its value at regular interval t, then t is called the period of this function. Here if we write f x plus t, then also we get fx, function of x, means at each regular interval t, the function f repeats its value, then t is called the period of this function. This is the case for the period of the function in real domain and real range, means dealing with the real numbers. In complex plane, this type of repetition of the functional value may be occurred, and at that time that complex number will be the period of this function. Now we work on the period of hyperbolic function. Let fx equal to sin hx. X may be real or complex, implies that f x plus 2n pi I equal to sin h x plus 2n pi I, and this is equal to minus I sin I x plus 2n pi I, since we know that sin hyperbolic x equal to minus I sin ix. It is a known thing, and this will be equal to minus I sin ix minus 2n pi. Here I multiply I square is minus 1. This will be equal to minus I sin, we take common minus 2n pi minus ix sine minus theta means minus sine theta multiply minus 1 sine 2n pi minus ix, and this is equal to minus I multiply minus 1 sine 2n pi minus ix means minus sine ix, and this will be equal to minus minus plus, here minus I sine ix, and which is equal to sine hyperbolic x, here minus I sine ix means sine hyperbolic x, and this is equal to fx. So here if we add 2n pi I with x, we get that the functional value repeats. Putting n equal to 1, f x plus 2, in place of n we write 1 pi I equal to fx, implies that f x plus 2 pi I equal to fx. So after the interval 2 pi I, the function repeats. Therefore 2 pi I is the period of hyperbolic sine function of x. Again, if we repeat this, f x plus 2 pi I plus 2 pi I, we get f x plus 2 multiply 2 pi I. Here in place of n we may write 1 2, here we have 2. So this will be also equal to fx. Hence at each interval 2 pi I, the hyperbolic sine function repeats its value. Therefore period equal to 2 pi I. Similarly, we may find period of hyperbolic cosine and tangent functions are 2 pi I and pi I respectively. Hence, we get that the period of hyperbolic sine and cosine function be 2 pi I, and in the case of tangent this is pi I. This period is pi I. That is, in the case of hyperbolic tangent, the period is half of the periods of hyperbolic sine and cosine functions. Now we expand hyperbolic sine function in series, since we know that Sin theta equal to theta minus theta cube by factorial 3 plus theta to the power 5 by factorial 5 minus dot 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 dot. Let this is number 1. Since sin hyperbolic x equal to minus I sin ix, and this will be equal to minus I, here we use 1, in place of theta we have ix. So we write here ix minus ix whole cube by factorial 3 plus ix whole to the power 5 by factorial 5 minus dot 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 dot. Here we take common I from each term, minus I multiply I. Here remains only x minus I square x cube by factorial 3. Here I to the power 4 x to the power 5 by factorial 5 minus dot 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 dot. Here minus I square means minus 1. Here x, here minus I square means minus 1 x cube by factorial 3. I to the power 4 is 1 x to the power 5 by factorial 5 minus dot 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 dot. Here minus minus plus 1, we only write here x minus minus plus x cube by factorial 3. Here x to the power 5 by factorial 5, and other terms will be also positive term, and we will get x to the power 7 by factorial 7 and plus dot 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 dot. This is the required expansion for hyperbolic sin x. Now we expand cos hyperbolic function in series. Since we know that cos theta equal to 1 minus theta square by factorial 2 plus theta to the power 4 by factorial 4 minus dot 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 dot. This is number 2 and this is number 3. Since hyperbolic cosine x cos hx equal to cos ix, and in place of theta we write ix 1 minus ix square by factorial 2 plus ix whole to the power 4 by factorial 4 minus dot 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 dot. This is equal to 1 minus I square means minus 1 x square by factorial 2 plus I to the power 4 is 1 multiply x to the power 4 by factorial 4 and minus dot dot dot. Here 1 minus minus plus x square by factorial 2 plus x to the power 4 by factorial 4 and other terms will be positive, and this is the required expansion for hyperbolic cosine x. Thanks for watching my video. If you are satisfied with my presentation, and contents, then please click on like button and do subscribe my YouTube channel. Thank you.